So we saw in class an example or two of how to use the limit definition of the derivative to find the derivative of a function, but we want to do just a couple more examples. And here we go. So we're going to find f prime of x, given that f of x is x minus 4 divided by x plus 3, and we're going to use the limit definition of the derivative. So let's start by writing down the solution, the limit definition. So f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, all of that divided by h. Okay, so let's keep our work nice and neat and orderly. This is the limit as h goes to 0. Now, f of x plus h. So here in f of x, wherever we see x, we replace that x by the expression x plus h. So let's go ahead and do that. So we will have 4 minus, and in parentheses, x plus h, because we're replacing the x with x plus h, all divided by 3 plus x plus h. And then we're going to subtract f of x. Now f of x is just f of x, so we can just copy it down. 4 minus x over 3 plus x. And this is all divided by h. Now, of course, we would like to be able to use the direct substitution principle, but we can't here because of the h in the denominator. We can't divide by 0, and so we have to do some algebraic gymnastics, I like to call it, some algebra, to remove that h from the denominator. So let's start here by first giving ourselves some more room to work. And second, let's see. So we're going to start by simplifying things. The first thing I'm going to do here is distribute this negative. I'm also going to remove the parentheses. And if you can hear music in the background, that's my boyfriend playing guitar downstairs, and there's nothing I can do about that. So here we go. This is the limit as h goes to 0 of 4 minus x minus h. And now 3 plus x plus h. Now let's think ahead a little bit back up here. So we're going to have to do some simplification. And so the first thing we're going to do is we see that we have sort of a compound fraction here, right? Like there's a fraction, we're subtracting another fraction or quotient, and then we're dividing it. And so we're going to want to simplify this entire expression. And so the first job we're going to have is to find a common denominator up in the quotient that appears in the numerator. And so we're going to leave ourselves some room for that. And so I'm going to say, I'm going to multiply this by something. I might not know what yet, but I'm going to leave myself some room to do it. And then we're also going to be multiplying this by something. Let's give ourselves a little bit more room here. Okay. And then this is still all divided by h. Now, what is the common denominator up here? Well, just like if we were adding a fourth plus a third, we would just multiply the denominators by one another. 4 times 3 is 12. That's the same thing up here. So the common denominator in the numerator is 3 plus x plus h multiplied, quantity multiplied by 3 plus x. And so this term here, we're going to multiply by 3 plus x. And now I'm going to go ahead and put parentheses around everything because I'm going to need to distribute in the numerator and 3 plus x in the denominator. And then over here, we're going to multiply by what we're missing, which is 3 plus x plus h. So we're going to multiply by 3 plus x plus h. Of course, we have to multiply by 1, otherwise we've changed the thing. We don't want to do that. I'm going to write some parentheses around here to remind us to distribute. So, is often the case when we're working these kinds of problems, things tend to get a little bit more complicated before they get simpler, and that's kind of the stage we're in right now. And so I'm going to have to, I've actually recorded this twice already, and I'm going to have to write kind of small to fit everything in this page. So forgive me if my writing gets a little bit sloppy here. So we've got the limit as h goes to 0. And so now we're just going to expand this expression in the numerator. We're going to have 12 plus 4x minus 3x minus x squared minus 3h minus hx. And now we're going to subtract, and we have to distribute all of this here. And I wrote the big bracket to remind myself to distribute this negative sign after we're done. And so hopefully I can fit this all in here. We're going to have 12 plus 4x plus 4h minus 3x minus x squared minus, oops, let's see if I can't, no, minus x squared minus x times h. And now this is all divided by h times 3 plus x times 3 plus x plus h. As I promised, things are going to start to get better now, because if we've done our job correctly, some nice things will happen. When we remove this negative sign, when we remove this bracket and distribute this negative sign here, we can see that this 12 and this 12 are going to cancel. What else is going to cancel for us? This 4x and this 4x are going to cancel. This negative 3x and this negative 3x. Bye-bye. What else is going to cancel for us? Let's do it in another color. This x squared and this x squared are going to cancel. And then finally, this hx and this xh are really just the same thing. Those are going to cancel. So let's see what we've got left. I think that things will be significantly more simple now. We have the limit as h goes to 0 of minus 3h minus 4h all over h times 3 plus x times 3 plus x plus h. So we have the limit as h goes to 0 of minus 7h divided by h, 3 plus x, 3 plus x plus h. And now these h's reduce. And this leaves us the limit as h goes to 0 of negative 7 divided by 3 plus x times 3 plus x plus h, which now the principle of direct substitution applies. We have 3 plus x quantity squared left in the bottom. And so that completes our example of how to find f prime given that f of x is 4 minus x over 3 plus x. And our final answer is here.